Guys, and welcome back. We are starting into Unit 2, Day 1. And so this is just going to be a video to help you fill out your notes that we went over in class. So you'll be able to identify key features of linear functions, and you'll do this from a context, a table, and a graph. So this first portion is just recalling from Unit 1. So remembering that an arithmetic sequence is just a sequence that changes by adding the same amount or a common difference. So the first part of this unit is really going to compare arithmetic sequences to a linear function and see how they are similar and how they are different, or if they are different. So in numbers 1, 2, and 3, and 4, we needed to write the explicit function. So remember that with your explicit function for an arithmetic, remember we talked about being the function n. So the term would be whatever your starting term was plus your common difference, and that would happen n minus 1 times. And it turned out that this whatever term number here is the number that went here. So when we look at number 1, we see that it is going up by 2 each time. And so we are adding 2. So we would have f of n is equal to 4 plus 2. And we'll do that n minus 1 times. And remember, we saw that in the table. So go ahead and try and do 2, 3, and 4 on your own, and then check your answers. Let's go ahead and take a minute or two to check your work for each of these. So you see that number 2 is decreasing by 11, starting at 94. Number 3 is increasing by 5, starting at negative 28. Remember, those terms are actually getting bigger. And then number 4 is adding 6 each time, starting at 2. So the first big main thing that we're going to do that's going to be new to us is we are going to be going from we could be going from a situation rather than just a sequence. So when we look at this first example of towing service, we see that when a tow truck is called, the cost of the service is $10 plus $1 per mile that the car must be towed. So we're going to write a graph and a linear equation and do all of these things. So the first thing we're going to do is we're going to define our variables. So we're talking about two different things. We're talking about a cost of service, and we are talking about a number of miles that a car is towed. So the thing that is the total is always going to be the y. So whatever is the combination of things will always be y, and the thing that we are changing will be the x. So the x is the independent variable. It's the piece that we can determine, that we know, that we choose for the equation. So x will be the number of miles, and the y is the dependent variable. So it's what comes out of using the x. So the cost, or the total cost, will be the y, because that's depending on how many miles we go. So when we want to fill in this table of values, the one thing to note is that I have it starting here at 1. The cost to go 1 mile is the cost for the tow truck to pick us up, $10, plus the $1 for the 1 mile that we went. So our total cost would be $11. For 2 miles, we would then go another mile, so it'd be $12. And for 3 miles, we would go just one more, which would be $13. You don't pay the $10 for every mile, you just pay $1 for every mile after the tow truck has picked you up. So your D is your common difference, right? And that is $1, because that's how much it changed by. We went up $1, so we added 1 for every 1 mile that we went up. The cost for no miles is actually $10, because that would be the term right above 11, or right before 1. So the explicit form will then be, we'll start with the first term. So if we would have f of n is equal to, we're starting at 11 and adding 1, n minus 1 times. When they want slope-intercept form, they want you to simplify. So I'm actually going to copy and paste this and move this. So when we want to simplify this, then we're just going to take our d and distribute it into our parentheses. So it would be 11 plus 1n minus 1. And then we would combine our like terms. So we would have 10 plus 1n. So we'd have f of n is equal to 1n plus 10. And I'm actually going to change it to y equals. So I'm just going to replace my f of n with y. And we're talking about x and y, so I'm going to make my n be x. So y will equal 1x plus 10, or even just x plus 10. Then we see we can graph this equation. So I'm going to graph my equation. So my x axis is my number of miles. My y-axis is my total cost. So I'm going to go ahead and graph those 2 points. So I actually went through and plotted 2 extra points, but you can see the points. Now, we want to think to ourselves, is there a cost for going 1.5 miles or 2.5 miles or 3.25 miles? And there is. You would pay something in between. So we do want to connect our points. And we can also go ahead and plot that the cost for no miles was at 10. So we can just go ahead and connect our points. You can see in the graph that my points go up 1 for every mile I went. So I counted by 2s because it wouldn't have fit on my graph. And I skipped a box for each mile to spread it out for you. But you can see that for every mile I go, which is half a box, I go over, 2 boxes is 1 mile. For every 1 mile I go over, I'm going up by $1. So it's $1 per mile, which should make sense to us because that's what our common difference is. And so what we'll learn is that our slope is the common difference. And so our slope is our cost per mile, which would be $1 per mile. The y-intercept is where the line crosses the y-axis, which is that point there at 0, 10. So it's your base cost of service. Which was $10. That's your flat fee, the thing that you pay just the one time. We see this in our equation because it was 1x and $10 to start with. So looking at the second one, t-shirt shop. Your new job is at the custom tee shop where t-shirts are printed to order. For each order, custom tee shop charges $8 per shirt plus a one-time setup fee of $15. So defining our variables, we will see that we have 2 things going on. The first thing is you're ordering t-shirts, right? So your total cost is going to be the Y, because that's your dependent. It'll depend on how many t-shirts you order. And the t-shirts will be the independent piece. So that's your X. So your X is your number of t-shirts ordered, while your Y will be the total cost. Now in my table of values, I want you to go from 0 to 2. So for 0 t-shirts, you will pay, if no one orders any t-shirts, or if you don't order any t-shirts, then it would be $15. just your setup fee. Then if you order 1 t-shirt, it's going to be $23. If you order 2 t-shirts, it's going to be $31. So we can see that our common difference, D, is $8, and our cost for no shirts is $15. So writing into our explicit form, we will have f of n is equal to, we start at 15, we add 8 times 8, n minus 0 times, because 0 is our starting term. So when we want to write that in slope-intercept form, we will distribute to solve. So we will have eight times n and 8 times 0, which would just give us 815 plus 8n. So again, switching our n's to x's and our fn to y, we'll have y is equal to 8x plus 15. So you can see the 8x and the 0 term in your explicit equation. When we graph it, make sure you label your axes. So our x was the number of t-shirts, and our y is our total cost. So we'll go ahead and plot those points from the table. Again, to fit it on the graph, I counted by 5s, so each box on the y-axis goes up by 5s, and I skipped every other box on my x-axis just to blow this up. If you order, so for this example, you wouldn't order half of a t-shirt, right? You would only choose to order full t-shirts. So we wouldn't want to connect these points because it doesn't make sense to buy 1.5 t-shirts. You would only buy whole t-shirts. So, but once again, we can see that this goes up by 8 for every 1 t-shirt we sell. So we see that common difference in our graph as the slope. So the slope is going to be the $8 per t-shirt. The y-intercept is, of course, where the graph touches the y-axis, so it is $15, and that's just your charge to order no shirts. It's your setup fee or your base cost, just like with the tow truck. All right. So your homework is on Desmos to do more examples just like these examples. Again, remember to ask questions in class if there's something that you are not understanding. This is what we've been doing for the last 2 days, and this is just to help you fill in your notes or get caught up if you were absent. I will see you tomorrow.